Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Do's and Dots. Not Don'ts, but Dots by Vushel. And here are the rules, excuse me. We have normal Sudoku rules, where we need to place the digits 1 through 9 in each row, column, and box without repeats. We have region sum lines, where box borders split blue lines into segments with the same sum. So, for example, this is a segment because it's split by the box borders. So is this, and so is this. So the sum of these two digits must equal the sum of these two digits, which must equal the sum of these two digits. It's the same thing with all of these. These must be adding up. That means these two add up to the same sum as this, which is equal to the same sum as that. And finally, we have ratio dots, where on a black dot, one digit is double the other. And we have difference dots, where the digits on a white dot differ by 1. Another name for these are called Kropke dots, and they're called black and white Kropke dots. So as an example, say this was a 2 here, then this would have to be 1 or 4 to maintain the 1 to 2 ratio, because this is a black dot between them. And say this was 6 here, then this would have to be 5 or 7 to make sure that these dots have a difference of 1, or in other words, are consecutive. So then those would be they would have to have a difference of 1 or be consecutive. It's the same thing, because there's a white dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. There's a couple of things that I see that are interesting. I'm not sure where to go, though. I think this one is probably the most interesting. The difference between these two cells is 1. To add up to the same sum, the difference between these two cells also must be 1 then, and the only digits that are in 1 to 2 ratio which have a difference of 1 are 1 and 2. So this has to be 1 and 2 here. We don't really know what this adds up to, though. So that's interesting. So this is a difference of 1. These must have the opposite difference of 1. This is another interesting thing. These two are in a 1 to 2 ratio. This can't be 1 or 2, so we have 3, 4, 6, 8 there. If 8 were here, we'd have to have a 4 there. If this is 6, that's 3. If this is 3, that's 6. If this is 4, it's 2 or 8. These add up to essentially what these digits are. But this cannot be ever 1 and 2. If this is 1 and 2, that means this adds up to 3 also, so it would also have to be 1 or 2, but the 1-2 pair in the column would eliminate all possibilities for that. So this has to be 2, 4, 3, 6, or 4, 8 here. Here we have one digit that is in a 1-2 ratio with 2 other unique digits. So it's either 2 with 1 and 4, or 4 with 2 and 8. And either way, we have to have a guaranteed 2 or 4 be one of these digits, right? 2 in a 1 to 2 ratio with 1 and 4. 4 in a 1 to 2 ratio with 2 and 8. So first of all, this can't be 2 and 4 as a pair because that would eliminate all possibilities for that. So this can't be 2. This can't be 1 and 2 here. That adds up to 3, and we have the same problem that we do here. That would therefore have to be add up to 3, which would mean there's a 1-2 pair here. So this is not 1. You could have 1, 2, and 4. Can you have 4 here? If you have 4 here, that would force this to be 2, which would force that to be 1, which is not possible anymore. So 4 is definitely one of these digits. So it's either 2 and 4 adding up to 6, or 4 and 8 adding up to 12. Well, we cannot have 2 and 4 here. That would force this to be a 1-5 pair to add up to 6. But then this has to be 1 and 5, or 2 and 4, again, adding up to 6. And it can't be either, because the 2-4 pair here would eliminate 2 and 4 here. The 1-5 pair here would eliminate 1 and 5 as a possibility here. So this can no longer be either 1-5 or 2-4. So this has to be 4 and 8, which makes that 2. This has to be a 3-9 or 5-7 pair, adding up to 12. 4 eliminates 4 as a possibility here, so this can't be 4-8. It's 3-6 as a pair to add up to 9. That eliminates 3 in the rest of the column. This must add up to 9. This must add up to 9. No 2 here because of 2 in the column. So this is either 1-8 or 4-5 here. This could be 1-8, or it cannot be 1-8 because of 1 in the row. Can't be 2 because of the 2 in the row. And it can't be 3-6 because of the 3-6 pair in the column here. So this must be 4 and 5. So we have 4 here, that's 5. This cannot be 4, 5 as a pair to add up to 9. So this must be 1 and 8. So we have a guaranteed 1 here. This is 5, so this cannot be 5. So we don't have 7 or 9 here. This must add up to 12 with that. 4 eliminates 4 here. So that means this cannot be 2 or 8. Remaining digits of row 6. We have 3, 6, 7, 8, and 9 as possibilities. Okay. No 8 here because of 8 in the column. This cannot contain 3 or 6 because of the 3-6 pair in the column there. Cannot be 4, 8, or 2, 4 because of 4 in the box here. So this has to be a 1-2 pair. That means we have a guaranteed 1 or 2 here. 1 can't be here because if this were 1, that would force this to be 2. Remaining digits of box 7, we have 4, 5, 2, 7, 9. No 2 or 4 here, no 4 or 5 here because of digits respectively in their column. Okay, so what are the possibilities here? These are consecutive, that's fine. These are consecutive. So these add up to an odd sum because they must be consecutive, so you're guaranteed an odd and an even number, which always adds up to an odd number. So you have to have one odd and one even here to add up to the odd sum here. So we're guaranteed, so these are all odds. We have odd here, even here. And we're guaranteed an odd and even here that eliminates evens in the rest of the rows because we have 4 evens. So these are all odd. So since this is odd, this must be even there. We have an odd even pair there. Remaining digits of box 4. We have 3, 6, 7, 8, and 9 again here. No 8 here because of 8 in the column. No 8 here because of the 1, 8 pair in the column. So 8 has to be here. Remaining digits of column 2. We have 1, 2, 7, 9, but no 2 there. So it's 1, 7, 9, which is an odd digit. Okay, what else do we have? Remaining digits of column 1. Could be 3, 5, 6, 7, or 9. Okay. Eight is even. Um, so this, I don't know. Okay. Well, so this is guaranteed to have a 6 here. 6 cannot be here, because if this were 6, 6 plus whatever digit here must equal 6 plus the other digit here. So this is 2, 4, or 8, which is consecutive with that. It's 1, 3, 5, 7, or 9 still. Can't be 2 and 1. That again adds up to 3, which would force a 1 and 2 there, but we can't have 1 and 2 there because of 2 in the row. We have to have 6, so this can't be 2. No 2 or 3. So you could have 4, 5 with 6 and 3. 4, 7. That doesn't work. So 4, 5 with 6 and 3. Or this is 8 and 7 with 6 and 9. Cannot be 8 and 9 because that would add up to 17, but you can't have two other digits here add up to 17 without an 8. So this is 5 or 7, which means this cannot be a 5-7 pair here, adding up to 12, because that would eliminate all possibilities for that cell there. So this has to be a 3-9 pair here. That means this can't be 3 or 9, because that would eliminate all possibilities for that cell there. So this is 5, that's 7. That eliminates 7 in the rest of the box and column. So no 7 there, no 7 there. 5 can't be here because of 5 in the column. We have a 2, 4, 7, 9 quadruplets in box 7, which eliminates 2, 4, 7, 9 in the rest of the box, so no 7, 9 there. It's 5. These again cannot be 5 here. We have a 3, 6, 9 triplet in row 2, which eliminates 3, 6, 9 in the rest of the row. So we're left with 1, 5, and 7. So either this adds up to 9, 3 and 6, or it's 6 and 9 here. But it can't be 6 and 9. If this is 6 and 9, that's 7, 8. And this would have to be a 7, 8 pair to add up to 15. So this must be 3 and 6, which makes this 5 and 4 to add up together. So no 5 here, no 5 here, so that adds up to 9 here. No 4, so no 4, 5, no 2, 7. So this it can't be 3, 6 because of the 3, 6 pair in the box, so this is 1, 8. That eliminates 1, 8 in the rest of the box, so this can't be 1. It's 7, which makes this 1 there. That eliminates 1 there, so it's 2 and 1 there. So this digit must be 1 less than this digit here. Otherwise, they don't add up to the same sum for this and this pair. So no 7 here because of 7 in the column. 3, 6 eliminates 3 here, so it's 9 and 3, which eliminates 3 here because of 3 in the row. Remaining digits of row 3, we have 2, 6, and 9, but this can't be 2 because of 2 in the column, which means the 2 remaining in column 3 has to be there. That leaves us 4, 5, and 9 remaining in box 3. That means this can't be 9 anymore. It's 1. No 1 there. 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 9. That leaves no more 9s remaining in box 7. So we have a 2, 4, 7 triplet here in box 7, that in column 3, which eliminates 2, 4, 7 in the rest of the column. So no 7 there. It's 3, 6, and 9 there. So this is 3, 6, or 9 there. Cannot be 9 because of the 4, 5, 9 triplet in the row. So this becomes a 3, 6 pair, which eliminates 3 and 6 in the rest of the box. So this can't be 6, it's 9, which makes that 6. 3 and 9 eliminate 3 and 9 here. This column. What are the possibilities here? You could have 3 and 4 here. That adds up to 5, but 4 can't be here. 4 and 5, no 5 here. So 5 and 6, no 6 here because of 6 in the column. 7 and 8 is not allowed. 8 and 9 is not allowed because of 8 in the row. So this has to be 5 and 6. So this pair cannot be 1, 6, 2, 5. Adding up to 7, it has to be 3, 4. But this can't be 4 because of 4 in the column. So that's 3 there and 4 there. Ooh, we have a problem here. That's bad. Where did I mess up? I think my logic made sense, but looking at it now, it's obviously problematic. This becomes a 1-2 pair. Hmm. Hmm. Yeah, it can't be 6 and 7 because of 6 in the column. Uh. Wait, why couldn't this be 6 and 1? That might be where I messed up. Yeah, that's where I messed up. Interesting. Well, now we know. 6 and 1 adding up to 3 and 4. 4 and 5 adding up to 6 and 3. Cannot be 6 and... Could be 6 and 9, but that doesn't work. Either way, this is 4. So 4 cannot be, again, it's 3 or 5 there. So either this is 3 and 6, which means this is 5, and that can't be 3. Or this is 3 here, which means this can't be 3 either. So 3 can never be there. That can't be 9. We just saw that this was problematic. Sums, right? Cannot be 1 and 2. No 2, 3. This has to, well, we don't know anymore. Okay. Can't... Well, we went down that path and we found a contradiction. I'm not sure how else to prove this. Okay, so we're guaranteed either this is 3 or 9, or this is 3 and 9. Either way, one of these is a 3. So that eliminates 3 in the rest of the row. If this is 6 and 1, this has to be 2 and 5. If this is 6 and 3, No 4, 5 here. This is 1, 3, 5, 7, 9. And we're guaranteed one of these is 3. That eliminates 3 in the rest of the row. 1 is guaranteed here, which means where is 1 in box 2? It has to be one of these two. So this must be 1, which means this can't be 1, so that must be 2, which makes that 1 there. Okay, so good that we have that information. So now we have these possibilities. 3 and 4 cannot, these again must be smaller than this digit by 1. No 3 and 4 there, therefore it could be 4 and 5. No, can't be 4 and 5. 2 and 4 add up to 6, which would force us to be 2 possibilities, 1, 5, and 2, 4. But they would both be eliminated by these possibilities. So 4 and 5, it could be 5 and 6. But that would again force this problem of 3 and 4 here, which would eliminate all possibilities for, well, all but one possibility for both of these cells, which means you would have a repeat there. So that doesn't work, and therefore it has to be 6 and 7 as a possibility. Cannot be 7, 8, cannot be 8, 9. So this has to be 6 and 7, which forces this to be a 3, 5 pair to add up to 8, which is what this is. That eliminates 6 and 7 in the rest of the box. That also eliminates 6 and 7 in the rest of the row, so this is a 3, 9 pair, which eliminates 3, 9 in the rest of the box there, so it's 6, 7 as a pair there. 3 and 5 eliminate 3 here, so that's 6, which makes that 3. 3 and 6 eliminate 3 and 6 there, so it's 4, which is only 1 and 2 ratio with 8. So this cannot be 8 here, no 8 here, no 8 here. Cannot be 8 and 9 adding up to 17. No 8 and 7 adding up to 15, because 4 plus another digit's not going to add up to that. Same with 8 and 6. Adding up to 14, 4 and 10 would add up to 14 there. No 4 or 5 there because of the 3, 5 pair in the row and the 4 in the row. So this has to be 8 and 3 here, which makes this not 3, that's 9. No 3 or 9 here. This 9 eliminates 3 and 9 as a possibility here, so this becomes a 5, 7 pair, which eliminates 5 and 7 in the rest of the box, so no 5 there. It's 3, which makes this 1 and 6. That eliminates 1 in the rest of the row. So no 1 here, no 1 here. Where's the 1 in box 2? Because we have the 1 there, it has to be here. 5 and 7 as a pair eliminates 5 and 7 in the rest of the box, so it's 9. No 9 there. And again, this can't be 5 or 7. That would eliminate all possibilities for that cell there. So this is 3 and 9. 3 eliminates 3 there, so it's 9 and 3. No more 9 here. 9 eliminates 9 there. 9 eliminates 9 there. We have a 2, 7 pair in box 7 now, which eliminates 2 and 7 in the rest of the box. So this becomes a 4, 5 pair. That eliminates 4, 5 in the rest of the box, so this can't be 5 or 7, it's 9. So, no 9 here, no 3 or 9 here. Okay. This adds up to 11. Cannot be 3 and 8. So 3 and 8 is 4 and 7 adding up to 11. This is either 2, 9 or 5, 6. And this can't be 5 or 6 because of the 3, 5 pair in the row and the 2 and the 6 in the row. So this has to be 2 and 9 to add up to 11. That eliminates 2 here. The 1 and 2 in row 5 can only be in these two cells, so this must be 1 and 2. That leaves 4, 5 remaining in row 5. And this can't be 5 because of 5 or 7 in the column. There's a 5, 7 pair in the column. So that leaves that 4, 5 there, 5 eliminates 5 there, so it's 7, which makes this 5, which makes that 7. 2, 5, and 7 eliminate 5 and 7 there, it's 6, which makes that 7. 6 and 7 eliminate 6 and 7 there, so it's 5. That leaves this as a 1, 7 pair in box 1. Okay, 5 is consecutive with 4 or 6. So this is 4 or 6 there. Remaining digits of box 5 are 3, 5, and 8. No 3, I guess we should do it this way. 3 eliminates 3 here, so it's 5 and 3. No 3 or 5 there because of 3 or 5 in the column, so it's 8. No 5 or 8 here, so that's 3, which makes that 5. Remaining digits of row 4 are 4, 6, and 9. 4 eliminates 4 there. Remaining digits of box 2, we have 2, 6, and 8. 2 and 6 can't be here because of 2 is 6 in the column, so that's 8, which leaves these as a 2, 6 pair. Remaining digits of column 5 are 4 and 7. This can't be 7 because of 7 in the row. So this is 4, which makes this 7. 4 eliminates 4 there, so it's 5 and 4. 7 eliminates 7 here, so it's 2 and 7. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so it's 7 and 1. 7 eliminates 7 here, so it's 6, which makes that 7. Whereas the one in column 9 cannot be here because of the 1, 6 and the 1, 2 pairs in the boxes. Can't be here because it must add up to 11 for the read and sum line. So 1 has to be there. Remaining digits of column 6, we have 2, 6, and 9. 9 cannot be here, and 2 can't be here. So that's 6, which makes this 2 and 6. That leaves that as a 9. 9 eliminates 9 here, so it's 2 and 9. Remaining digit of row 3 is specifically an 8. Remaining digit of column 9 has to be 4 or 6, but this can't be 6 because of 6 in the row, so this is 4, which makes that 6, which makes this 9, which makes that 4. Remaining digits of row 1, we have 3 and 9. This can't be 9 because of 9 in the column, so that's 3, which makes that 9. Remaining digits of row 7 are 1, 2, and 8. This can't be 1 or 2 because of 1, 2 in the box, so this is 8, which makes this 1, which makes that 8. That leaves that as 2. Remaining digits of column 4 are 1 and 8. This can't be 8 because of 8 in the row, so that's 1, that's 8 there. That leaves this digit as a 6. 6 eliminates 6 here, so it's 1 and 6. 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 5 and 2, which leaves this digit as a 3 and this digit as a 5. Apologies for that. I messed this part up. I removed the 3 too prematurely there. It happens sometimes. Yeah, pretty cool, actually. The idea behind these region sum lines was very interesting. I should have basically generalized it to basically where you had to have 3 sets of unique digits adding up to a single digit. So that would definitely preclude any sum from 6 or below and any sum from 14 or above. So that means these sums had to be between 7 and 13. So, anyways, I hope you enjoyed the solve even with my mess up, and I'll see you next time on Frank Puzzles. Take care.